Hey everyone, and welcome back. Before we begin here today, please make sure that you like and subscribe because it really does help out our channel. And it also helps us reach others who want to test their math skills with these types of test questions. So this will be our 46th part in this particular series. And what we have going on here is that we have to find the area of the blue region shown inside of this parallelogram. So we are told a bit of information and shown a bit of information. So A, B, C, D is in fact a parallelogram. A to B is 4 centimeters. A to D is 2 centimeters. D to Q, which are boundary lines for our blue region. So D to Q and P to B are circle arcs with a center at A. And we're also told that this angle in here is 60 degrees for A. So in order to find our blue area here, we have to find the areas of a few other pieces. So let's imagine that we have a straight line going from A up to P. So we are going to have to find the area of this partial circle sector from A, P, and B. So we would have to find the area of our sector, which I'm just going to call PAB. So that would give us this bottom portion here. And then with this line going from A to P, we also have a triangle forming here from A, D, and P. So we would also have to find the area and add that to the circle area. So we would have to find the area of our triangle ADP. So that would give us this total area here. It would get everything in blue, and then it also gives us this white circle area or circle sector area from ADQ, and we're just going to have to subtract that off to get our final blue area. So we would just subtract off the area of our sector. Oh, sectors with an O, not an E. Our sector DAQ, and that would give us our final blue area. So a few things that we need to find here in order to determine what exactly is going on with these areas and how to find them. So what we need is that we're going to need some distances, we are going to need some angles and whatnot. So let me draw some additional lines here. So I'm just going to draw a nice vertical line that intersects here at 90 degrees, and let's just call this point down here at Y. And we're going to do the same thing over here at P. We're going straight down, intersecting AB at 90 degrees, and let's just call this one X. So in order to determine all these areas, all these angles, I need to know what dy is. I need to know what px is, and I need to know what p A is, this length from P to A as well. So if I can get those three lengths, that will help me out tremendously. Also, I would need to determine angles here. So I would need to determine this angle PAX, which would be this one right here for the circle sector. And I would also need to determine the opposite of that, which is DAP. Now, some of these are going to be very quick to get, but we need all of this information in order to find out our areas here below. Okay, so starting with our dy. Let's work on getting dy first. We'll work on our lengths and then we will get our angles here. So looking at dy, what I have going on is I have this triangle ADY with 60 degrees here. It is a right triangle. So what I can do is that I can just use my right triangle with my sine of 60 degrees in order to get that side dy. So dy is essentially just 2 centimeters because that's my hypotenuse times the sine of 60 degrees, and that would give me this opposite side of dy, which pops out to be exactly square root of 3 centimeters. Okay, well, that's dy checked off. Well, what about px over here? Well, it is a parallelogram. So dy is the height of the parallelogram throughout. Px is also the height of the parallelogram. So dy will essentially be equal to dx here. So px is just equal to dy, which is the square root of 3 centimeters in height there. Pretty simple formula right there. All right, so the next length I need is my A to P. Well, looking right here where it says PB is a circle arc with center of A. Well, A to B is 4 centimeters. So as you go along this arc, that is essentially the radius of that circle. Well, P is along the radius or along the arc of the circle. So A to P will just be your radius of that circle, which is, once again, well, A to B. So that would be 4 centimeters. So AP or PA, however you want to write it, is equal to AB, which is equal to 4 centimeters. Alrighty, so super hard there to get on those lengths. So now we have all those lengths needed. Well, what about our angles here? Well, we're looking to see if we can get this angle here, which is my PAX, and then use that 60 degrees to get my other angle for my triangle ADP. This angle right here for APX inside this triangle right here will give me the overall portion area of the circle sector APB. So let's work on getting that one first, and then we can go over here and we can get this angle just by subtracting 60 degrees. So once again, we're going to use right triangles here because now this length of AP, well, that is 4 centimeters in length, and we know this height over here, which is equal to the square root of 3. So not super difficult to get any of this information. We're just going to use the same right triangles here, or the same kind of right triangle idea. So we would have the sine of my angle PAX, which is equal to PX over AP. So it'd be my opposite over my hypotenuse, which is going to be square root of 3 centimeters over 4 centimeters, which would be equal to my sine of my angle. So this would be square root of 3 over 4. Thus, using the sine inverse of square root of 3 over 4, my angle PAX will pop out to be 25.66 degrees. So this angle right here is 25.66 degrees. So how do I get the other angle inside that other triangle up here, which is the triangle from ADP? Well, this is a total of 60 degrees. So taking 60 and subtracting off 25.66, this angle up here is 34.34 degrees. So now I have both of my angles here. So what I can do is I can go ahead and I can find the area of my sector, my circle sector APB, add that with the area of my triangle ADP, and then subtracting off this little white circle sector here of ADQ. And we're going to be utilizing this angle right here of 25.66 degrees with a radius of 4 centimeters for the first area. And then we're going to be utilizing our 1/2 base times height here for our triangle of ADP, utilizing this angle right here to get my height because I'm going to use the 4 centimeters as my base. And then lastly, using the 60 degrees here with my radius of 2 centimeters for this circle sector in white. So utilizing all that information, let's go ahead and write the equations here. They're not super complex with this problem once you break it down. So the area of my first sector, which is the larger circle sector of PAB, would just be my angle within that circle sector of 25.66 degrees divided by the total of a circle, which is 360. So it gives us our portion there, which will be pi times the radius squared, which is 4 centimeters. And this gives us an area of 3.58 centimeters squared for my first circle area. Alrighty, so now moving on to the second portion, which is the area of triangle ADP. Well, this is just going to be 1/2 base times height. So I have 1/2. My base of my triangle is 4 centimeters. And just to refresh you here, we're looking at this top one right here. So my base is 4 centimeters. And then I just need my height right here, which, well, once again, another right triangle, and I can use that angle of 34.34 degrees in conjunction with the 2 centimeters to get that overall height there, which essentially will just be 2 centimeters times the sine of that angle, which is 34.34 degrees. And so my total area of triangle ADP pops out to be 2.25 centimeters squared. Oh, that is an ugly M there. So let's rewrite that real quick. So this would be my height, or this would be my base, sorry. The 4 centimeters was my base, and this would be my height for my triangle. Okay, the last little area portion that we need to find is the area of that white circle sector, which is DAQ, which this one is pretty simple because we were starting with the angle of 60 degrees. So portion that out. So we would have 60 degrees over 360, which is basically 1/6 of the circle area times pi times the radius, which is 2 centimeters squared. And this gives me a total of 2.09 centimeter squared. So what I have found so far is the area of my entire circle sector right here of APB, the area of the upper triangle of ADP, and then that gives me this total region here, including the blue and this white circle sector. So I need to subtract off the white circle sector here of DAQ to get the area in blue. And we have all those values, so let's go ahead and do that. So my blue region inside this parallelogram will simply just be 3.58 centimeters squared, so, or adding together with the triangle area of 2.25 centimeters squared, and then subtracting off that white circle portion of 2.09 centimeters squared. And this gives me a total blue area of 3.74 centimeters squared. And that's how you would work that particular problem. Well, at least that's one way that you could work to predict the problem. Usually these types of skill videos presented on this channel, there are typically multiple ways that you can work a single problem. This was just one way that you could possibly, or the possible procedure that could be used in order to find this answer. So, hope you enjoyed this video. And learned a new math skill along the way. And if you want to test your abilities even further, please check out the other videos on the channel. Also, if you haven't done so already, please like this video, leave a positive comment below, and subscribe to the channel because all of that does help us out. Thank you for watching, and I hope you have a fantastic day.